Now let us go over to another very important term that is called as direction ratios, which are typically denoted by the letters A, B and C. Now what are direction ratios? The definition is given here. Any non-zero constant multiples of direction cosines of a line are called as direction ratios of that line. So if we multiply the direction cosines, we know that direction cosines are denoted as L, M and N, correct? So if we multiply L, M, N by a constant non-zero number, then whatever new set of three numbers we get, that is called as the direction ratios of the line. So it is clear that we can multiply by any non-zero number. So therefore, as written next, a line has unique direction cosines but infinitely many direction ratios. So let's take for an example, suppose the direction ratios of a line are 0, 1 upon root 2, minus 1 upon root 2. Now suppose we multiply all the numbers by root 2, then we will get 0 is to 1 is to minus 1, correct? So basically, being the ratios, we can also think of these numbers to be in the given ratio with each other. Okay, so instead of comma, we can visualize it as the ratios also. Now we can multiply this last set once again by some constant factor, non-zero factor, say 2. So then that turns out to be same as 0 is to 2 is to minus 2, isn't it? So therefore, in this way we can see that there will be countless such sets of direction ratios for a given line, but the direction cosines represent a unique triplet of these three numbers. Okay, so that is the important point to keep in mind. Now let us see how the direction ratios are related with direction cosines, and how do we derive direction cosines if we know the direction ratios, right? Direction ratios, as we know, they are denoted by A, B, C, and direction cosines means L, M and N. Now since direction ratios are basically some multiples of direction cosines, they are obviously in ratio with each other. So we can say that L upon A has to be same as M upon B, and that has to be same as N upon C. And let's consider that this ratio, common ratio, is equal to say lambda. Now we have to find out the relation and a method to convert ABC into LMN. Now from this, can we say that L is equal to A lambda, because we can do the cross multiplication. So therefore L is equal to A into lambda. Similarly, M is equal to B lambda and N is equal to C lambda. Now we have already proven the relation between LMN, that is L square plus M square plus N square is equal to 1. So therefore, by substituting the values of L, M and N from above, we get A square lambda square plus B square lambda square plus C square lambda square is equal to 1, and hence taking lambda square common, we have A square plus B square plus C square is equal to 1. So therefore lambda square is 1 upon A square plus B square plus C square, and hence lambda is equal to plus or minus 1 upon root of A square plus B square plus C square. So we got the value of that common ratio, that is common factor lambda, in terms of the given quantities A, B and C. So now since we have got lambda, we can substitute it in these three formulae. So therefore we will get L as plus or minus A upon square root of A square plus B square plus C square Similarly, we can say that M is equal to plus or minus b upon square root of the same quantity, and n is equal to plus or minus c upon square root of the same quantity. So in this way we can calculate L, M and N from A, B and C. But now in these formulae, that is wherever we are seeing plus minus and so on, it does not mean that for L you can pick up any value, for M you can pick up any value, and N you can pick up any value. No, it's not like that. What it means is, see that plus or minus basically comes from the two possible values of lambda, isn't it? So if you take the plus, that is a positive value of lambda, then in all the three formulae of LMN you will have to consider positive value only. On the other hand, if you consider the negative value of lambda, then in these three formulae you have to consider everywhere the negative value. Right? Of course, the final sign of L, M and N can be positive or negative based on the signs of A, B and C themselves. So depending on whether A, B or C is itself positive or negative, the final sign will vary. But as far as taking plus or minus is considered, that clearly follows from lambda, and hence you will get only two sets of L, M and N, right? By considering all the three plus on the right side in the formula or all the three minus on the right side of this particular formula.